This presentation is part of the TI-Nfocus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2018 AP Calculus exam, free response question AB4 BC4. My name is Steve Kokoska. I'm a professor at Bloomsburg University of Pennsylvania, and I am a former AP Calculus chief reader. Here is an outline of the information presented in this video. I'll start by reviewing the free response question and the scoring guidelines that were used at the AP Calculus reading. I'll present a brief general summary for student performance on this question. And then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors, and where appropriate, I'll present some specific scoring examples. This problem involves the height of a tree and a table of values. The height is given by a twice differentiable function h, and selected values of h of t are given in the table. In Part A, use the data in the table to estimate h' of 6 and interpret the meaning of h' of 6 using correct units. In Part B, explain why there must be at least one time t between 2 and 10, such that h' of t is equal to 2. In Part C, use a trapezoidal sum to estimate the average height of the tree over the interval 2 to 10. And finally, in Part D, a new function capital G is given, which models the height of the tree as a function of its diameter. The diameter of the tree is increasing at a rate of 0.03 meters per year when the tree is 50 meters tall. We need to use this model to determine the change in height of the tree with respect to time when the tree is 50 meters tall. Part A was worth 2 points. 1 point for finding the estimate of h' of 6, and 1 point for the interpretation using the correct units. Part B was also worth 2 points. 1 point for writing an appropriate quotient that results in a secant line slope of 2, and 1 point for demonstrating the conclusion is true using the mean value theorem. Part C was worth 2 points. 1 point for writing a correct trapezoidal sum using the values in the table, and 1 point for finding an approximation to the average height of the tree over the interval 2 to 10. Part D was worth 3 points. 2 points for finding the derivative of g with respect to t, and 1 point for the final answer, the rate of change of the height of the tree with respect to time when the tree is 50 meters tall. Note that there is a maximum of 1 out of 3 points in this part if the student does not use the chain rule. Here are some general comments about student performance on this question. In Part A, most students recognized that in order to approximate h' of 6, they needed to use a difference quotient, and most students formed this difference quotient using the appropriate interval 5 to 7. But a common error involved the use of the interval 3 to 7. Many students were not able to communicate a complete interpretation of h' of 6, and in their interpretation, many students failed to specify the exact moment in time, t equals 6. And the explanation here involved a rate, and many students had trouble conveying that concept, or simply did not recognize this expression as a rate. In Part B, many students knew that in order to reach the conclusion, the mean value theorem was necessary. However, several students did not know to use the table of values to find a subinterval that led to a secant line slope of 2. And in their conclusion, many students did not cite the assumption of continuity, which is necessary for the mean value theorem. And there was another way to reach this conclusion, using the intermediate value theorem, Well, along with 2 applications of the mean value theorem. This was a valid mathematical approach, and if presented correctly, the student received full credit. In Part C, many students successfully demonstrated the use of a trapezoidal sum for approximating the integral from 2 to 10 of h of t dt. However, some students attempted to apply the so-called trapezoidal rule, which did not apply to this problem, since this rule requires subintervals of equal width. Some students did not multiply their sum by 1/8 to find the average height of the tree, and there were lots of communication issues here. For example, students who did not sufficiently convey a trapezoidal sum. In Part D, most students were able to apply the quotient rule, or some actually used the product rule. However, since x is a function of t and we want dg dt, the chain rule is necessary here, and many students computed only dg dx. There were many errors in notation in Part D. It appeared that many students confused or misinterpreted variables, or even introduced their own variables. And some students used x equal 50 to find their final answer, rather than first solving g of x equal 50 for the value of x. Here are some interpretations of the scoring guidelines. The first point in Part A was for the estimate, and to earn this point, the student must present both a difference and a quotient. Simply, students must show their work. A bald 5/2 or a 5/2 presented without any supporting work does not earn this point. The second point in Part A was for the interpretation, and there was no eligibility rule here. So if a student could not approximate h prime of 6, they could still correctly interpret this expression and earn the second point. Now, there were 3 items necessary in the interpretation. The meaning of h connected to the tree, well, the height of the tree or just the height. The meaning of the derivative as a rate of change with the correct units, meters per year. And the meaning of 6 as t equals 6 or 6 years. The units here could be included or attached to the approximation for h prime of 6. That is, not included in the written or communicated explanation. Students could refer to the tree rather than the height of the tree. Students could also refer to their specific approximation, 5/2 or 2.5 in this case, rather than the general expression h prime of 6. And the readers did accept some alternate phrasing for the concept of rate, and some awkward explanations of the specific time t equals 6, as long as the student did not refer to an interval of time. In Part B, the first point is for writing the appropriate quotient that leads to a secant line slope of 2. And consistent with Part A, the student must present at least one difference and a quotient. The student's response may include prose, but they still need to produce a difference and a quotient. The second point in Part B is for confirming the conclusion using the mean value theorem. Now, there's an eligibility criteria here. The student's response must be connected to our problem, and that is that the student must be using the appropriate subinterval and secant line slope. The student's response must explicitly declare the continuity of h. The student may indicate that h is increasing, but this is not a substitute for stating that h is continuous. If the wrong theorem is referenced, for example the extreme value theorem or the intermediate value theorem, the student does not earn the point. The response cannot simply be a general statement of the mean value theorem. And there's an alternative method for solving this problem using the mean value theorem twice and then the intermediate value theorem, which, if presented correctly, would earn both points in Part B. In Part C, the first point is for presenting the trapezoidal sum. This is a method or conceptual point, separate from the approximation point. If the student makes an arithmetic or linkage error, which is connecting unequal expressions with an equal sign, after earning the trapezoidal sum point, they do not earn the approximation point. We need to see the multiplication leading to the correct trapezoid areas and evidence of a sum. Once again, students need to show their work in a logical, comprehensible manner. And if the student makes only one error in presenting a clear trapezoidal sum, they still earn this first point, but are not eligible for the second point. The second point in Part C is for the approximation. This point is earned for our answer only. The student does not earn the point for a bald answer, an approximation without any supporting work. And again, this point is not earned if there is a linkage error. Here are some examples of responses in Part C and how they would be scored. In the first example, the trapezoid areas are evident and there is a sum. The student earns the first point, and additional work may earn the second point. The second example is almost minimal for the first point. We can barely see the trapezoidal areas and there is evidence of a sum. In the third example, there is insufficient evidence of a trapezoidal sum, but the student could still go on to earn the approximation point. In this example, the student has made two errors. They started the sum at the point 0, 0, and the area of the triangle is incorrect. Now, note that if the area of the triangle were correct, the student would earn 1, 0, not eligible for the approximation point. In example 5, there's one error in the trapezoidal sum. The student earns 1, 0. And in example 6, this student computes the trapezoidal sum by correctly finding the mean of the left and the right sums. They earn the first point. Here are a few more examples. In the first, the student has split each trapezoid into a triangle and a rectangle, found each area, and presented a sum. They earn the first point. In the second example, the student has presented a correct trapezoidal sum and multiplied by 1/8 to find the average height of the tree, all in one step. And since this is a numerical answer, it does not need to be simplified. This response earns both points. And the last example shows a linkage error. This response earns the first point, the trapezoidal sum point, but not the approximation point. In Part D, the first 2 points are for finding the derivative of g with respect to t. We need to see a correct product or quotient rule and the chain rule. If the student presents simply dg dx without the chain rule, they can earn one of the first 2 points, but they're not eligible for the third point. And here are some examples. In each case, the student earns 1 out of the first 2 points and is not eligible for the third. An incorrect dg dx with the chain rule may earn 1 out of the 2 derivative points. First, dg dx must look like an attempt at the quotient rule of the product rule, and certainly there's some professional judgment here. dg dx must be a rational function in x. It cannot simplify to a constant or polynomial expression. And a single error in dg dx with the chain rule may be eligible for the third point, but there were only 4 special cases. If there were other errors in dg dx with the chain rule, the student may still earn 1 out of 2, but they're not eligible for the third point. And when there are notation errors, if there is a correct quotient or product rule, the response earns 1 point. And the student can only earn the third point for our answer. The third point in Part D is for the answer. The response must be our answer, except in the 4 special cases mentioned previously. These 4 cases involve a single error in dg/dx with the chain rule. And here are the 4 special cases. In each case, the error is highlighted in red. There is a single error in dg/dx, and the student has produced the correct consistent answer. In each case, the student earns one of the first 2 derivative points and the answer point. Here are a few more examples associated with Part D. These first 2 demonstrate reasonable attempts at the quotient rule. There is also evidence of the chain rule, but neither example is one of the 4 special cases. So each earns one of the first 2 derivative points and is not eligible for the third. And here are some examples with notation issues. In each case, the student earns one of the first 2 derivative points and is eligible for the third. If they can resolve the bad notation and arrive at the correct answer, they can earn the third point. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. There is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.